So let's look at a little bit more complex situation where we have a flip with a shift. Now with the y's, it's not as complicated because the flip with a shift, since we don't have to do anything backwards, when I see this flip and shift down, I can see that it's going to be algebraically done the right way around. So it's going to be the flip first, algebraically, and then we're going to do the minus after. Okay, so on the outside, it's not too bad. Okay, so this is pretty straightforward. The x's, there's no change in the x's. So we're just going to have negative 3, 0, 3. Okay, so what was this before? This happened to be a semicircle function. Okay, these are our 3 reference points for the semicircle function. Okay, so none of the x coordinates have changed. So what's happening with the y coordinates? Well, we're going to flip and then shift, and we don't need to do anything backwards. So my change in y, my new y is going to be flip first, shift second. Okay, let's make sure that's clear. Equals negative y naught, and then minus 3. So negative, minus 3, negative, minus 3, negative, minus 3. I'm going to give you these coordinates. So to kind of visualize what that's going to look like, it's going to be upside down and then down. So when I actually track these coordinates, negative 3, negative 3, 0, negative 6, 3, negative 3, it gives us the graph that we were kind of expecting. Okay, so y's are pretty straightforward. What we see is what we get. So flip first, shift last. Okay, so we started with this semicircle function. We ended up with an upside down semicircle shifted down. Okay, well that's pretty straightforward. The more complicated situation comes in when we have x's. Okay, what happens when we do x's? Well, x's are done opposite of what we see. So here I'm seeing a flip, shift left, and the order, I have to kind of think backwards. Well, I'm going to flip first with my algebra, so it should be flip last, which means that that's going to be shift first. Now that's kind of hard to keep track of. Okay, so now if you can do that in your head, that's all right. But really, we shouldn't be doing too many steps backwards. We'll lose track of things. We really should start using our undoing strategy, because the undoing strategy is going to be concise. We know how to do it. It's just steps for solving an equation. It's undoing the calculations. And when we undo the calculations, we're not going to do things backwards anymore. We're just going to do the things the right way around. So we don't have to be thinking backwards all the time. It's much easier to walk forward than to walk backwards. So we want to turn everything around so we're walking forward. So I'm just going to write it this way. Here's my change in x. So there's no change in y, but we'll deal with that afterwards. My notation looks like this. Okay, this is what my notation is. And if you want to keep track of this, this is what is basically going back to the old x calculation so we can put it into our original table. But it's just backwards. Okay, so if I want to undo this backwards, I can undo this backwards algebraically, because solving is the opposite of calculating, which then is going to undo or go backwards through our function notation. So I'm going to do the minus first, and then I'm going to flip last. So algebraically, this is what it looks like. This is what I'm going to actually do. I'm going to do this. So I'm going to take these x's, I'm going to do that to get new x's. So I'm going to subtract 2 and flip, so I get 4. Subtract 2 and flip, so I get 2. Subtract 2 and flip, so I get 0. And the order in which I do it is now clear here. I don't have to think backwards when I look at this anymore. I just have to look at this and say, what I see is what I get. This is what I'm going to actually do. I'm going to minus first, flip last. Here it's kind of hard to see because we have to think backwards. And when we think backwards, it's easy to trip ourselves up. So to not have to worry about any backwards thinking, I solve for the other x. And that way I have everything in the order I want it. So there's my transformation. Okay, so with my y's, there's no change in y, so I'm just going to keep all my y's the same. I'm going to sketch this parabola. Okay, my original parabola is at 0, 0, 2, 4. Okay, so this is my original parabola. It's going to look like that. Okay, so in this case here, what happened? Well, we shifted to the left first, and then we're going to flip the vertex across the y-axis. So we should end up with a vertex over here. Okay, so my graph should look like this over here. Okay, now the parabola is symmetrical, so when we flip it, okay, it's going to still look like a U, but we should still have the main thing is if we can track the vertex, we can see exactly what happened. So we should shift to the left and then flip, so we should end up on the right hand side. So when I graph these points, 4 over, 4 up, okay, there's a point there, 2 over 0, 0, 4, there it is. There's my vertex, and it's in the spot that I kind of expected it to be. It ended up being on the right hand side because I shift left, flipped across the y-axis, I'm going to end up on the right hand side here. So this is the correct parabola, and the order now is done in the correct way. And because I solved for this x, I undid all this the notational calculation. I'm going to do it in the right order. Okay, so this notation is backwards, so I solve it to do everything, undo all the calculation. Now I get to do everything in the right order. Okay, so that's the purpose of why I want to solve for that other x. So the y transformations, pretty straightforward. They're done in the order you see them. Okay, what you see is what you get, so it's pretty straightforward. But the x calculations, we have to be extra careful, okay, because we want to do everything in the opposite. And it's really hard to do things backwards, especially multiple steps backwards. Okay, it's hard to think of which one goes first, the opposite operation. Not only are we doing the opposite, we're doing the reverse order. And it's really hard to keep track of unless you have some concise method. And this is going to be our concise method to keep track of the order in which we're going to do things backwards.